at, at high altitude there is low atmospheric pressure. As there is low pressure in the atmosphere, so in the alveolar the pressure will be also reduced. So the alveolar partial pressure of oxygen in the alveolus will also get reduced. As there is low oxygen pressure in the alveolus, so there will be low oxygen diffusion from the alveolus to our artery. So eventually the partial pressure of oxygen in the artery will also get reduced, and when the partial pressure of oxygen in the arterial system will get reduced, this condition is called hypoxemia. When hypoxemia develops, it stimulates our respiratory center, and when our respiratory center gets stimulated, ventilation rate increases. When the ventilation rate increases, to increase the reduced partial pressure of oxygen in the artery, this increased rate cannot compensate this reduction, but at the same time when the person is hyperventilating, he start to lose carbon dioxide from his blood. So partial pressure of carbon dioxide in the artery get reduced. As we know, carbon dioxide can produce oxygen, can produce acid by reacting with water. When oxygen is getting out from the blood, so we can say our acid is getting out from the body. As acid is getting out of the body, body develops alkalosis, so pH of the body increases. This alkalosis is called respiratory alkalosis. By the other hand, when hypoxemia develops, it will also increase the production of erythropoietin from the kidney. When erythropoietin level increases, it stimulates the bone marrow to increase the erythrocytosis, and erythrocytosis increases, and red blood cell mass will also get increased. That will increase our hematocrit in the blood. When hypoxemia develops, as there is reduced oxygen in the lungs vasculature will contract, and this contraction will increase the pulmonary vascular resistance. The artery of the lung will contract because the artery of the lungs will try to shift the blood from the low oxygenated area to high oxygenated area. So this increasing pulmonary vascular resistance will produce pulmonary hypertension, and eventually it will cause right ventricular failure. And also in the hypoxemia, the RBC will also try to increase the glycolysis. When the glycolysis is increased, as a byproduct, 2,3-bisphosphoglycerate will also get increased, and 2,3-bisphosphoglycerate will bind with hemoglobin, and this will reduce the affinity of hemoglobin to oxygen. When affinity of hemoglobin to oxygen increases, it will shift the oxygen hemoglobin dissociation curve towards the right, and that is depicted as increase in P50 value of the oxygen hemoglobin dissociation curve, and this the condition is called acclimatization.